In this video, I'm going to give you 30 reasons why you should consider FreeCAD as your main CAD tool, whether it's for personal projects or professional work. So let's get started. The first reason, and the most obvious one, is that FreeCAD is completely free. No need to create an account or make your files public. It's free, and it's free for life. The second reason to choose FreeCAD is that it's one of the only CAD softwares available on all operating systems. You can use it on Windows, macOS, or Linux. No need to be forced into upgrading to Windows 11 and throwing away your old computer just because it can't update. That's Microsoft's idea of ecology. The third reason is that the software truly belongs to you. Once you download it, it's yours. You don't have to upgrade to a newer version, and you can even do a bit of digital archaeology by using a much older version. The fourth reason is that FreeCAD is open source. You have full access to the code, and you can modify it to improve it or add new features. Good examples are AutoCAD, the Rails under Link branch, or OnCell, which all build on the same source code and improve it. You're free to do whatever you want with it. The fifth reason, and I never thought this would become a positive thing to say because it should be obvious, is that you don't need an internet connection to use it. The sixth reason is that, because it's open source, there are no commercial restrictions. You can sell your projects and monetize your creations freely. If you do that with a free or maker version of Fusion, Onshape, or SolidWorks, get ready to be swatted at home. The seventh reason is that every week, FreeCAD fixes bugs and adds new features in their development version. This lets you test new features before they make it into the next stable release. I look forward to every Wednesday like a kid waiting for Christmas. The eighth reason is that you can easily customize FreeCAD's user interface and make it your own. You can move all the menus, add new toolbars, change the theme, and even change the icons to match your taste. The ninth reason is that you can model using simple primitives. You don't have to rely on complex sketches if you don't want to. For example, this kitchen cabinet was modeled entirely with primitives. The workflow is very simple. We started by generating a cube and assigning dimensions to it. Here we began with a side panel. Then it's just a matter of copy and paste and using the transform tool to move the different boards. It's pretty much the same process as if you were modeling this in Blender. Keep in mind that this method is very simple and fast, but if you change a value on one board, the others won't update. If you want it to be fully parametric, you need to use a different approach. The 10th reason is that if you want more complex models, you can use the sketch system to design them. Sticking with the kitchen cabinet example, this time it's driven by a sketch, so you can easily change the dimensions and the model updates automatically. After that, you just extrude the outlines and you get your cabinet. FreeCAD also has all the modeling tools you need, like revolution, loft, sweep, symmetry, and all their cousins. For example, to model this bike fork, we used several of these tools. For the steerer, we started by creating a sketch and applied a revolution operation. Then we hollowed it out with a thickness operation and finished with a pocket to allow tire clearance. To create the legs, we first defined the path for the pipe operation, along with the 3 different cross-sections. Then we created an additive pipe. After that, we used the pocket to cut the tube, then a thickness operation to hollow it out. To finish, we used a Boolean operation to cut it to the shape of the steerer, and then we finished with a symmetry. Then the last piece of the puzzle, the dropouts. We started with an extrusion, followed by a Boolean operation to cut it to the shape of the legs, and then a symmetry to get the second part. Through this example, you can see that FreeCAD really has all the tools you need to model any part you want. The 11th reason is that you can take parametrics to the next level using variables. For example, here I made a box with dovetail joints, where I can easily change the shape or size of the joint while keeping the box dimensions intact. And you can go even further with variables like this bike chainring, fully driven by variables depending on the number of teeth, or this carport where you can change the size and number of roof battens without having to modify the sketches. The 12th reason is that you have full access to the history of your operations. You can go back to the very first steps and modify them. Before FreeCAD 1.0, models tended to break if you didn't take certain precautions. Since this version, modifications are much more stable. The 13th reason is that you can create macros and integrate them directly as tools. They're powerful tools that can save you a lot of time and help you perform complex operations. These macros are written in Python, so you can create them yourself. In this example, it's a macro that creates a symmetric pad operation. I just need to create a sketch and run the macro. A window pops up asking for the extrusion length, and the operation runs smoothly. But as you can easily imagine, you can set up much more complex operations. I also set up a pocket through all macro. If you combine these 2 macros with keyboard shortcuts, you can model very quickly. And you don't need to know Python programming to create macros, because you can simply record your operations. By going to the add-on manager, you can also download macros created by the community. Don't hesitate to take a look. The 14th reason is that you can easily create complex part assemblies using an approach very similar to Fusion in the assembly workbench. Each assembled part is a link, and you can edit it directly inside the assembly. These can be created in a static way or in a dynamic way, with degrees of freedom for motion, like in the basic mini excavator example. The 15th reason is that you can create exploded views directly in the assembly workbench. Let's take this wooden deck as an example with multiple parts. With just 2 clicks, the exploded view is created. It's stored in the tree view, so you can reuse it later for a drawing. The 16th reason is that you can directly create a parts list from your assembly. You can export it as a CSV file or keep it as a spreadsheet and reuse it later in a drawing. Speaking of drawings, the 17th reason is that you can create technical drawings from your 3D models directly in the TechDraw workbench. You can choose which views to import and then add dimensions and annotations. You can even go further by importing an exploded view, the parts list, and creating balloon annotations for an assembly drawing. Oh, and I almost forgot to mention that the drawings are linked to your 3D model, so if you update the model, the drawing and all the dimensions update automatically. The 18th reason is that you can export your drawings as PDF files, unlike the free version of Fusion where that option is reserved for paying users. The 19th reason is that you can have a live link between FreeCAD and Blender to create ultra-realistic renders of your parts. And a big thank you to Frank David Martinez, who developed this live link. You can export your file directly to Blender, and when you make changes in FreeCAD, you can update it without losing your textures. I'll put the link to his GitHub for the installation. The 20th reason is that you can import a wide variety of file types. That includes solid files like STEP, but also 2D files like SVG or DWG, and even mesh files like STL, which is very useful for 3D printing. Speaking of 3D printing, the 21st reason is that FreeCAD has all the tools you need for it. On top of all the modeling tools, you also have the mesh workbench to edit polygons, repair meshes, and convert them into solids. I've already covered this topic. I'll put the video link in the description. But if there's one tool to remember, it's Rahix's macro-fused filament, which lets you create tear holes and other very useful functions for your prints. A second tool is the Gridfinity or Free Grid Storage System workbench, perfect for creating easily 3D printable storage solutions. Before moving on to the next reason, a quick message from our longtime partner, PCBWay. They are simply leaders in PCB manufacturing, 3D printing, and CNC machining. You just upload your file, select the options, which are very detailed and complete, and you get an instant quote. I've tested their service several times, and the results were always perfect. Don't hesitate to take advantage of their offer, especially since you get a $5 coupon on your first order. A huge thank you to PCBWay for sponsoring this video. The 22nd reason is for our woodworking friends, the Woodworking Workbench. You don't need modeling skills to use it. You can simply generate a base and work around it or keep it as is. You also get an automatic cutting list, perfect to prepare your project. This workbench is developed by D Project and is very complete. If woodworking is your thing, it's a must-have. And don't be intimidated by all these tools. They're really there to minimize all the modeling steps as much as possible. Staying in the manufacturing tab, the 23rd reason to try FreeCAD is the CAM workbench. Here, after creating your part, you can generate the different toolpaths for your CNC. You can do simple projects like this small bowl or more complex ones like this bike chainring. You can create your own bits, set their speeds, and even do 4th axis machining. Of course, you can also choose the post processor that matches your machine. I'll put links to several projects where I use this workbench and show how to use it. The 24th reason is for architecture and construction enthusiasts. FreeCAD has an amazing BIM workbench that lets you create any project while following professional standards. All the essential tools are there. You can generate slabs, walls, windows, and doors in just a few clicks. The roof tool adapts to all kinds of complex geometries. It's a truly complete solution that can also automatically generate your 2D drawings from your 3D model for permits or construction documents. And most importantly, for collaborative work, you can export your files in IFC format. This lets you open your project in any viewer on the market and exchange structured data with other building professionals, with no software barriers at all. And I'd like to say a big thank you to Yurik for developing this workbench. It's an incredible amount of work. The 25th reason is a dedication to all the cavemen out there, the Fasteners workbench. Before discovering it, I was modeling my screws and bolts by hand. But with this tool, you can generate a huge range of fasteners that follow different standards. You can choose the type, the size, and the length, and edit them after they are generated. You can also select the edge of a hole, and it will automatically create the fastener at the correct size. No more modeling fasteners yourself. No more searching the internet to download them. Everything is right there, available through the add-on manager. The 26th reason is that you can run FEM simulations in FreeCAD. For example, here I ran a simulation on a handlebar, applying vertical forces at the ends to identify critical areas and check whether the tube thickness is properly sized. The workflow is actually quite simple. Once the part is modeled, you jump into the simulation workbench. You start by creating an analysis, then you assign a material to the part. Here I'm just picking a steel at random for demonstration purposes, but if we want to be precise, we should use 4130 chromoly steel. Next, we apply a fixed boundary constraint where the handlebar will be attached to the stem. For this simulation, we're assuming that this spot stays completely fixed. Next, we apply the forces where the rider places their hands. In this case, at both ends of the handlebar. At first, the forces aren't applied in the right direction, so we select the Z-axis of the part and click on direction. We also need to reverse the direction, since it should be applied as a pushing support. Finally, we apply a 1000 Newton force, which corresponds to a significant impact. To run the simulation, we first need to convert our part into a mesh. This part really deserves a full tutorial because it's important that your mesh is well made and fine enough in the right areas. For now, since this is just a demonstration and not a full tutorial, we'll simply select the part and use the NetGen tool. To make the calculation faster, we'll set the maximum mesh size to 10 and uncheck second order. Next, we need to run the simulation. Go to the tree view and open the Solver CCX tool. Since we're doing a static simulation, make sure static is checked, then click Write INP file. Once the file is written, you can click Run Calculi X to start the simulation. Once the simulation is finished, we can go to the CCX Results tab to see the results. Here I've chosen to display the von Mises stress, so we can clearly see the critical areas where stress concentrations occur. Looking at the results, we can see that the maximum stress stays below the steel's limit, with a safety factor of around 1.5. We also have the option to see how the handlebar deforms under the applied stress. The deformation is exaggerated to give a better visual idea. You can also make a quick animation to see it in motion. Here I've only shown a quick static simulation, but you can also perform a frequency analysis or even a thermomechanical study. You can also refine your parameters to get results that are as close to reality as possible. This example was just a quick demonstration. Sometimes you simply can't model certain shapes with basic solid tools, which is why we're at reason 27. To handle these parts, we use surface operations. For this bike saddle, we relied on two key workbenches, curves and surface. The saddle is built around this surface. To create it, we had to use several sketches. The central ones lie on a single plane, but at the ends you can see the sketch exists in 3D space. To create it, we combined two sketches, one from the top view and the other from the side view. We were able to do this using the Mixed Curve tool in the Curves workbench. I especially encourage you to explore this workbench if you want to create complex models. It allows you to make free 3D curves, which is incredibly useful. It's also a great tool if you work with mesh scans, since you can create curves that follow the surface of the mesh. Here on the screen is the example I used in a video where I compared FreeCAD and plasticity. I'm using the interpolation tool to create a curve that passes through the points of the object. Back to our surface. Once we've created the skeleton with our sketches and curves, we go to the surface workbench and use the filling tool. First, we need to select the boundary curves, then the curves that act as constraints. After selecting them, you get a nice smooth surface. Surfacing is part of complex modeling, and this is just a glimpse of what you can do with FreeCAD. The 28th reason to use this amazing program is that it comes with a huge library of pre-modeled objects, which can be really useful. It's located in the BIM workbench. You can insert a wide variety of objects into your project to bring it to life. Some of them are even parametric, so you can tweak the different settings to get the dimensions you want. The 29th reason to use FreeCAD is that there are tons of resources to help you. First and foremost, there's the wiki, where you can find the user manual, installation guides, and explanations of all the tools. There's also the forum, where you can post your questions or find answers. Moreover, you can check out FreeCAD's Twitter and Reddit pages, where you can find tips and tricks. FreeCAD is an amazing software with lots of techniques, but the best way to improve is by modeling yourself and following video tutorials. On my channel, you'll find a wide range of topics, from mechanical modeling to woodworking and even architecture. If you're really into BIM, I recommend following the FCB Lounge channel. For complex modeling, check out Dui Quangdang. If you are interested by the woodworking workbench, take a look at D Project channel. For understanding how the tools work, the videos from Mango Jelly are very good. For the CAM workbench, follow opensource CNC channel, and I'm sure I'm forgetting others. The 30th and final reason to consider FreeCAD is the software's future. The first chart shows its popularity among developers. Over the years, more and more people have been drawn to it. We can correlate this with the chart below, which shows FreeCAD's revenue, mostly coming from user donations. We don't have the 2025 numbers yet, but with the release of version 1.0, the figures should be even higher. These two indicators are a strong green light for the software's future, and I wanted to end on this positive note. I hope these 30 reasons made you want to give FreeCAD a try and showed you that it's not just a toy, but a professional-grade tool. Feel free to tell me in the comments why you use this fantastic software. I'd love to hear your thoughts. Thanks for watching until the end. If you enjoyed the video, don't forget to like and subscribe. See you next time.